Okay, so I have two objectives from Chapter 10, Objective 9 and Objective 14. So first, Objective 9 is talking about using formulas MC delta T and VC delta T. That's not division, but they're just the same formula. They're like using the same, they're going to give you the same answer, just uses different units. So I have an example here. We're trying to find the amount of heat and the amount of energy used when you cool 2 liters of water from 22 degrees Celsius to 10 degrees Celsius. And for this example, we're going to use VC delta T because we have volume. VC delta T stands for volume plus your, well, I like to say constant, but it's the specific heat capacity or the volumetric heat capacity. And for water, it's always 4.19. So that's why it's sort of like a constant. So, and delta T is the change in temperature. So then you just plug it into the equation. And actually, 4.19 is kilojoules per liter times degrees Celsius. And then we would have to subtract this. That's 12 degrees Celsius. So how I just took these, this is our 4.19 term, and then this is the difference between 22 and 10 degrees Celsius. It's pretty simple. And then when you do the math, you get 101 kilojoules. And you notice how liters cancels out with liters, and Celsius cancels out with Celsius, so it's just kilojoules. So that's how you would calculate with those formulas. And then Objective 14 talks about heating and cooling curves. I'm going to show you the different kinds of energy, the different states, and the phase changes, where those are at. So this is what a graph would look like generally. Time is on the bottom, temperature is on the side. These flat areas, time keeps going, but temperature does not change because it's in the middle of a phase change. So I'm going to label these. Those are our phase changes. And during phase changes, only potential energy is changing. So I'm going to write that down below. Potential energy. Potential, and it's the energy of position. And then kinetic energy is changing when this line is slanted, when temperature is increasing. So I'm going to write that off to the side. Kinetic energy. And this is not changing while kinetic energy is changing. Potential energy is not changing while kinetic energy is changing. They're completely different. They change at different times. And then the states would start at a solid, and then you would melt to get to a liquid, and then you would boil it to a gas. So, therefore, this is the melting point, and this is the boiling point. For water, boiling point is 100 degrees Celsius, freezing point is 0 degrees Celsius from that system. And then it works with it can go up and down for any substance. Pure substance. This is the graph for pure substances. So, there you go.